Review 7, Systems of Loop Equations A. Here's our circuit, and we want to know the magnitude and direction of the current in each resistor. Whenever we have a case like this, we're going to set up a system of equations. First thing we do is we put in some assumed currents. So I'm looking at this battery and I'm thinking that there's going to be a current that goes that way. And I'm looking at this battery and I'm thinking that there's going to be a current that goes like that. We don't know that for sure, but we are assuming. And if that's true, then right here where my pen is pointing now, those two currents will flow together and they will both travel in that direction. And the amount of that current will be I1 plus I2, according to what I've drawn here. Then when that current gets right here where I'm pointing with my pen, I1 is going to go that way and I2 is going to go that way. You can see that my assumed currents are all internally consistent. Let's set up a system of equations, and we need two equations here. We have three loops that we could choose from. There's the left loop, the right loop, or the all the way around, and we only need two of those. I like to draw a little point there. I'm going to do that point. I'm going to go clockwise, and I'm just going to go around the left loop. All right, so here we go. 38 minus, okay, now look here. I don't know if this is going to mess up the picture, but I'm going to draw it in there anyway. You see that 3 ohm and that 5 ohm resistor? You see, you got I1 going through the 3 ohm, then it combines with I2 for a bit, but then it's only I1 again by itself through this 5 ohm resistor. So I could write minus 3 I1 and then later on write minus 5 I1, but I'm just going to combine those and say, you know what, it's going to be minus 8 I1, taking those two together into account. But we're also going through this center 4 ohm resistor. So I'm going to write minus 4 times the quantity I1 plus I2 equals 0. What will this look like if we simplify it? This will be 38, and then the I1 will be negative 12 I1 and minus 4 I2. That's going to equal 0. That's one of our loop equations, and remember, we need two of them. So let's do another one. I'm going to do the right loop. I'm going to start at that little star point right there, and that's where I'm going to end. Start and stop at the star. I'm going to go counterclockwise, and I'm just going to go around the rightmost loop. So the loop that we're not doing here is all the way around the horn. We're not doing all the way around the outside. If you wanted to do that one instead of the right loop, you could do it. You know, you might want to try it. Stop the video and try it and see if you get the same answer at the end that we do. All right, here we go. We're starting at the star, so we go 18 volts. And then one more time. You see the I2 passes through this 6 ohm resistor, but then later on it passes through the 7. So I'm just going to combine those in one term. That saves me a little bit of writing. Okay, 6 plus 7 is 13. But don't forget the middle portion here. Minus 4 times I1 plus I2. We've already taken into account that 7 ohm resistor on the bottom, so now we're just back to our starting point. So what does this simplify to? 18. We're going to do the I1 first. We want them in order. Don't put the I1 first in one of them and the I2 first in the other equation, because you want to make sure when you put it into your calculator that all the I1s are lined up. Negative 4 I1. And so what is this? This is going to be negative 17 I2. 17 I2 equals 0. Those are the two equations, and you could solve those without a graphing calculator, but if you know, it makes your life easier if you know how to use a graphing calculator. It's less work. And how do we do this? We want the constants on the other side of the equal sign. We want all the I stuff on the one side. And hopefully you can see from these equations, if I put the 38 on the other side, it'll be negative. Well, then everything will be negative. So just to make my life easier, I'm going to make them all positive. So there's the first bit of my matrix. That's the first row of my matrix. Same thing down here. If I put the 18 on the other side, it'll be negative. Well, then everything will be negative. So how about just everything positive? 4, 17, and 18. Let's put that into our calculator here. There we go. Graphing calculator, turn it on. Go to second matrix. We're going to go to edit. And this is a 2x3 matrix, so that's nice. And we put these in just like we're reading a book. Hit enter after each one. 12, enter. 4, enter. 38, enter. 4, enter. 17, enter. 18, enter. Looks good. Let's quit. Go back into matrix, second matrix. Now we're going to do some math on this. And we want to go down, toggle down till you get to RREF. Hit enter. And now you need to put the matrix in there that you want. So we need to go second matrix. And because we've kept things really simple, matrix A is the one that's selected. I'm going to hit enter. And now I want to hit enter to make it do its work on there. And according to what we have here, our answers are I1 comes out to be 3.05 amps, and I2 comes out to be 0.34 amps. Now, the fact that those are both positive means that we happened to guess correctly when we drew our original currents in there. So that looks great. All right, so I'm thinking that through the 3 ohm resistor, we're going to have 3.05 amps. 3.05 amps, and it's going to be going that way. Through the 5 ohm resistor, also 3.05 amps, and it's going to be traveling to the left, that way right there. We'll do the easy ones first. Let's do the 6 ohm resistor. That's got only I2 going through it. So through the 6 ohm resistor, we're going to have 0.34 amps, and we've chosen the correct direction here. We know that because the current came out positive. And through the 7 ohm resistor, I think we're going to have 0.34 amps as well, and it'll be traveling that way. And through the 4 ohm resistor, we have the sum of those. Can we do that? 3.39 amps, and it's traveling in the direction that we chose. Yeah, we got lucky there.